Welcome to the lecture 8 of the Basic Foundation Physics lecture series. In this lecture, we are going to learn about work done and power. In physics, work is said to be done by a force when it produces a displacement in the body on which it acts in any direction except the direction perpendicular to the direction of force. If W is work done by force, if F is the magnitude of force, S is the magnitude of displacement, and theta is the angle between force and displacement, then work done W is defined as F is cos theta. Work done is a scalar quantity and SI unit of work done is joules, which is represented by capital J. And before we proceed, let's first discuss the values of cos theta for different angles. Value of cos theta at 0 degrees is equal to 1. For theta is equal to 30 degrees, cos theta is equal to root 3 by 2. For theta is equal to 45 degrees, cos theta is equal to 1 by root 2. For theta is equal to 60 degrees, cos theta is equal to 1 by 2. And for theta is equal to 90 degrees, cos theta is equal to 0. And for obtuse angles, cos of 120 degree is minus 1 by 2. Cos of 135 degrees is minus 1 by root 2. Cos of 150 degrees is equal to minus root 3 by 2, and cos of 180 degrees is equal to minus 1. For acute angles, values of cos theta is always positive. For obtuse angles, values of cos theta are always negative, and for theta is equal to 90 degrees, cos theta is 0. And work done is equal to Fs cos theta. So when theta is less than 90 degrees, work done by force will always be positive, and when theta is greater than 90 or less than equal to 180 degrees, then work done will always be negative, and for theta is equal to 90 degrees, work done by force will always be equal to 0. When force and displacement are in the same direction, then we can say that the angle between force and displacement is 0 degrees, and in that case F will be equal to Fs cos 0, and value of cos 0 degrees is 1, so work done will be equal to F into S. And when force and displacement are in the opposite direction, then angle between F and S will be equal to 180 degrees, and in that case work done will be equal to Fs of cos of 180 degrees, and value of cos 180 degrees is equal to minus 1. So work done will be equal to F into S into minus 1, which is equal to minus F into S. And when force and displacement are in the perpendicular direction to each other, then we can say that theta, the angle between F and S, will be equal to 90 degrees, and in that case work done will be equal to 0. We will now solve few examples based on the concepts that we have discussed. And in the first example, a horizontal force of 10 Newton magnitude is applied on a block of mass 2 kg, and if this force produces a displacement of 5 meters in the time interval, then we have to find work done by force F in this time interval, work done by gravitational force, and work done by normal force. In this question, if we mention all the forces acting on this block, then force F is acting in this direction, mg is acting in the vertically downward direction, and normal force on this block, which is exerted by the surface, will act upwards, and this object will displace in horizontal direction in the direction of this force. So for the first part, work done by force will be equal to magnitude of force into magnitude of displacement into cos of angle between force and displacement, and in this case angle between F and S is 0. So work done will be equal to F into S, and magnitude of this force is 10 newtons and displacement of block is 5 meters. So work done by force F 3 joules. For the second part, work done will be equal to magnitude of force into magnitude of displacement into cos of angle between displacement and force, and in this case angle between displacement and force mg is 0, so work done by gravitational force will also be equal to 0. And for the third part, work done by normal force will be equal to magnitude of force into magnitude of displacement into cos of angle between normal and displacement, which is again equal to 90 degrees. So work done by normal force will also be equal to 0. The next example, a block of mass m is lifted to a height h above the ground surface by a force F which is acting in the vertically upward direction, and we have to find the work done by this force F and work done by gravitational force on this block. So work done by this force F on the block will be equal to magnitude of force into magnitude of displacement into cos of angle between force and displacement, and in this case the angle between force F and displacement is equal to 0 degrees. So work done will be equal to F into h, and work done by gravitational force will be equal to magnitude of gravitational force into displacement into cos of angle between gravitational force and displacement h, and in this case displacement is in vertically upward direction but force mg is acting in vertically downward direction, so angle between gravitational force and displacement will be equal to 180 degrees. So work done will be equal to mgh into cos of 180 degrees, which is equal to -1. So work done will be equal to minus mgh. Next topic that we have to study is power, and it is defined as the rate of doing work. It is denoted by capital P, and power P is equal to work done per unit time. So power P is equal to W by T, where W is the work done and T is time. And it can also be expressed as Fv cos theta, where F is the magnitude of force, V is the magnitude of velocity, and theta is the angle between force and velocity. It is a scalar quantity, and SI unit of power is watt, which is denoted by capital W, and other commonly used unit of power is horsepower, and 1 horsepower is equal to 746 watts. Let us solve an example based on the definition of power. In this example, it is given that lungs perform 2.4 joule of work during each expansion, and we have to find the number of times they expand per minute if their power is 2 watts. Power of lungs is equal to 2 watts, which is equal to 2 joules per second. This means that in 1 second, lungs do 2 joule of work. So in 1 minute, total work done by lungs will be equal to work done in 1 second into time, which is equal to 60 seconds. So 120 joule of work will be done by lungs in 1 minute, and in each expansion lungs perform 2.4 joule of work, so number of expansions in 1 minute will be equal to total work done by lungs in 1 minute upon work done in one expansion, and this ratio is 50. So the number of expansions in 1 minute will be equal to 50. This is our final answer. I hope this video was helpful. Thank you.